When you look up at the stars, have you ever felt that thrilling, dizzying sense of scale? That feeling you're standing on the shore of some vast, undiscovered ocean? Well, that feeling is more real than you can possibly imagine. The truth is, we are all living inside a cosmic bubble, and we can't get out. The light from whatever lies beyond the edge of our bubble simply hasn't had enough time in the history of the universe to reach us. It's a border made not of walls, but of time and the unbreakable speed limit of light. So, what if we could peek past that boundary? What bizarre, mind-bending realities are waiting out there in the dark? For most of human history, that was a question for philosophers. But today, it's one of the hottest questions in all of science. Brilliant new theories are finally giving us a glimpse of the strange and infinite possibilities just beyond our view. And the answers they're hinting at are wilder than any science fiction. First, to understand what's beyond, we have to get our heads around the boundary itself. Because it's not a wall or some physical edge, it's just a horizon. This is the observable universe. A perfect sphere of space with you at the very center. Right now, the edge of that sphere is about 46.5 billion light-years away in every direction. Hold on, if the universe is only 13.8 billion years old, how can we see something 46.5 billion light-years away? Great question. The answer is that the fabric of space itself has been stretching ever since the Big Bang. So, while light from a distant galaxy may have only traveled for, say, 13 billion years, the space between here and there has expanded in the meantime, carrying that galaxy much, much farther away. And this expansion is speeding up, pushed along by a mysterious force we've nicknamed dark energy. This leads to a deeply weird conclusion. Regions of space beyond our cosmic horizon are moving away from us faster than the speed of light. And since nothing can travel through space faster than light, no signal or ray of light from those regions can ever reach us. They are cut off from us forever. We can't see them, and they can't see us. So you have to ask, what's out there, in that forever unseen territory? So, what's the simplest, most straightforward scientific guess for what lies beyond? Just more of the same. An endless continuation of the cosmos we already know. This idea comes from something called the cosmological principle, which says that on the very largest scales, the universe is basically the same everywhere. If that's true, then beyond our horizon is just an endless web of galaxies, stars, and cosmic dust, stretching on forever. It's an idea that's both simple and absolutely staggering, but infinite has some truly mind-melting consequences. If you have an infinite amount of space, but a finite number of ways you can arrange particles, then any possible arrangement must happen somewhere. Not just once, but an infinite number of times. This means that somewhere, unimaginably far away, there's another Milky Way galaxy. Inside it, another solar system just like ours. And on a planet identical to Earth, there's another version of you. Maybe it's a you that chose a different breakfast this morning, or a you who is living out the life you would have had if you'd taken that other job or moved to that other city. Have you ever wondered what might have been? In an infinite universe, another you is living it right now. But what if the answer isn't just more of the same? What if the very birth of our universe hints at something even crazier? This brings us to a powerhouse theory in cosmology: cosmic inflation. Inflation theory says that in the first tiny fraction of a second after the Big Bang, we're talking a trillionth of a trillionth of a trillionth of a second, the universe exploded in size. It went from smaller than an atom to astronomically larger than our entire observable universe, in literally the blink of an eye. This theory is a pillar of modern cosmology because it perfectly explains some big puzzles about the universe, like why its temperature is so uniform everywhere. Its predictions have been confirmed with incredible accuracy. But here's where it gets wild. Inflation suggests that the patch of space that became our universe is just one tiny speck of what was created in that initial burst. Some models suggest the full extent of space could be at least 10 to the power of 2-3 times larger than everything we can see. That doesn't make us a grain of sand on a beach. It makes us a single subatomic particle on a beach the size of a galaxy. And the theory gets even weirder. Certain models of inflation predict that it might be eternal. While inflation stopped in our little corner of space, allowing things to cool down and form galaxies, it could still be happening in other flung regions. New universes could be constantly popping into existence, like bubbles in boiling water, each one a self-contained cosmos created when a patch of space finally stops inflating. This is the multiverse, a vast, maybe infinite, ocean of other universes, all disconnected from one another. And they could be totally alien. They might have different laws of physics, different particles, maybe even more or fewer dimensions. Some could be cold and dead. Others could host forms of life we can't even begin to imagine. It's a humbling thought. Our entire cosmos might be just one bubble in an endless churning sea of creation. Beyond other universes, there's another huge question. What is the actual shape of our universe? Einstein's theory of relativity tells us that the stuff in the universe, all the mass and energy, curves the fabric of space-time. The overall density of the universe, then, determines its overall shape. There are three main options. If the density is too low, the universe has a negative curvature, shaped like a saddle and stretching on forever. If the density is too high, it has a positive curvature, like the surface of a sphere. A spherical universe would be finite, but if you flew in a straight line long enough, you'd end up right back where you started. Then there's the third, Goldilocks option. If the density is just right, the universe is flat like a sheet of paper and infinite. So, which one is it? For decades, our best measurements from satellites like WMAP and Planck show that our universe is astonishingly close to being perfectly flat. The margin of error is less than 1%. This flatness is actually a key prediction of inflation theory. But flat doesn't mean boring. A flat universe can still have a weird shape. Imagine an old-school video game where walking off the right side of the screen makes you reappear on the left. That screen is a flat, 2D torus the shape of a donut. Our 3D universe could be a giant version of that. It could be a finite, 3D donut that just looks infinite because light wraps around it, meaning we might be seeing multiple images of the very same galaxies in different parts of the sky. So, what's really out there? An infinite plane of duplicate worlds where every choice you ever could have made is playing out. A bubbling foam of other universes with alien laws of physics? Or is our entire existence just a finite loop, like a cosmic video game? The honest answer is, we don't know. And that's the most exciting part. These aren't just late-night dorm room questions. They are the absolute frontiers of human knowledge, being actively explored by scientists right now. Every new image from a telescope like James Webb could hold another clue. This journey to understand what's beyond our horizon is really a quest to understand reality itself. It forces us to ask the biggest questions about our place in the cosmos. We're like ancient explorers on one tiny island, staring out at a vast, mysterious ocean, knowing that the greatest discoveries are still out there, just waiting for us beyond the edge of what we can see. If these are the kinds of questions that get your brain buzzing, be sure to like this video and share it with a fellow wanderer. Let us know in the comments which one of these wild theories you find the most mind-bending.